Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, sketch a graph of a function f that is differentiable on the interval -3 to 4 and that satisfies the following conditions. The function f is decreasing on the interval from -1 to 3 and increasing elsewhere on the interval -3 to 4. The largest value of f is 6 and the smallest value is 0. The graph of f has local extrema at -1, 6 and 3, 1. So the first step is to analyze the given interval on which the function is differentiable. Now a function is differentiable on an interval if there is no vertical asymptote, no jump in the function, or no cusp point. So the given interval represents the domain of this function. That means the graph that we draw should be within this interval. We should not sketch the function outside this interval. Now we are also given that the function is decreasing from -1 to 3. And we are given that it's increasing elsewhere on the domain -3 to 4. So now we have to write the intervals over which the function is increasing. Now the domain starts at -3 on the left side and the decreasing interval starts at -1. That means the function is increasing from -3 to -1. Also the domain ends at 4 but the decreasing interval is ending at 3. That means the function is increasing from 3 to 4. So there's a very important concept we need to understand to solve this type of problem. So these are the two intervals on which the function is increasing. Now we are also given the largest value of f is 6, so that's the absolute maximum. And the smallest value is 0, so that's the absolute minimum. Now we are also given the local extrema at -1, 6 and 3, 1. So the first step is to plot these two extrema points because these points also lie on the function. So the first point is -1, 6 here and the other one is 3, 1 here. Now we can analyze the first extrema, -1, 6. Now we are also given that the absolute maximum is at 6 and that represents the y coordinate of the absolute maximum point. So that means this local extrema -1, 6 is the local maximum. So that means the function is increasing on the left side of x equals -1 and decreasing on the right side of -1, which is also shown by the intervals we got that the function is increasing on the left side of -1. So we can draw a graph which is sloping upward from left to right. And on the right side of -1, the graph has to slope downwards. Now the decreasing interval is from -1 to 3. That means the graph should slope downward from left to right from -1 to 3. Now the increasing interval is from 3 to 4. So that means we have to show the graph sloping upward till x equals 4. And we should stop at x equals 4 because that's the upper limit of the domain. Now we are given that the smallest value is 0 or the absolute minimum is equal to 0. So that can be shown by extending the curve on the left side all the way to the x-axis at -3 because -3 is the starting value of the domain. So I'll just redraw it. So this is the absolute minimum value. So these are the steps you have to keep in mind to solve a problem like this one. So in order to sketch a function with this type of given information, it's very important to analyze the information carefully and then graph the function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.